All right, this is going to be Chapter 10. Today we're going to cover 10.1, and it has to do with quadratic functions. All right, so you will need a graphing calculator every day. If you have one at home, please bring it in. Right? I'd rather you having work with your calculator than one of mine. If you don't have a calculator, I've got 24 of them here that you can use. Okay, so that's no problem.
Why would we have to bring it out?
I just said, you have to bring in your own because I'd rather you work with one of yours so that you get used to working with yours. I just said that.
Oh, so what if it's the same as yours?
Okay, well, Sydney, I only have 24 calculators, so I don't have enough for the whole class. So if everybody brings in their own, that would be great. Quadratic functions. What do you want, Kevin? You can look up in the cup on my desk. Quadratic functions. When you graph a quadratic function, we get a U-shaped curve. We call that a parabola. All right? That's what a quadratic equation looks like when you graph it. And if we write this in function notation, we know that f of x is the same as y, correct? And if we have an equation with degree 2, that is quadratic. All right? If we make a table of values, and this is how I want you to graph, but if we make a table of values, let's take some positives and negatives. Usually we want to pick 5 numbers here. And I think good numbers to pick are -2, -1, 0, 1, and 2. Okay? So what happens when x is -2? What would y equal? What is it?
4.
4. All right? -2 squared. If you're going to plug this into your calculator, please make sure you use parentheses. Whenever you put in a number for a variable, use parentheses. If you don't, you will get a wrong answer. Okay? If you were to put this in your calculator, and I think we know this, your calculator will give you -4. All right? So you've got to be careful, and that's the right answer. But if you're going to insert a number with a variable, please use parentheses. Okay? What if x is -1? What is y going to be? 1. If x is 0, what is y? 0. If x is 1, and if x is 2, 4. All right. Now, this is a sketch of f of x equals x squared, or y equals x squared. And what I want you to do on your paper, if you have to graph these, of course, we know that this is the origin. And then we have -1 and 1. Okay. Now, you can make your own marks. I hope to be able to get graph paper for you guys. And pick small numbers. We don't want to pick big numbers here. Right? And so I have -2 and 4. That's going to be right here, -2 and 4. We have -1 and 1, -2 and 4, 0, 0. We have 1 and 1, right there. And then we have 2 and 4. All right? So you can make your own marks and just sketch the graph. What do you think will happen if we took x squared and added 3? What do you think would happen if you graph that? What do you think, Emily?
Probably the 30. Start at the 30.
So you would think that this whole parabola, you would move it up 3 units? So that it would look like this. Let's do it in a different color. So you're saying this parabola would look like this. It would just move up 3 units.
Yeah.
Yeah, and that's correct. Okay? If it were a negative number, what happens to the parabola? It would shift down.
What about changing it so it's this way?
So it's upside down?
Yeah. Instead of getting, would you get a maximum?
What do you think? Kevin, what do you think? Yeah, pay attention up here, please. Zach, what do you think? How could we turn that parabola upside down? Yeah, yeah. If we put a negative in front of the variable, not in parentheses, but if we put a negative in front of the variable, it would turn upside down. So we're going to do some experimenting with that. In your graphing calculator, I'm going to try and talk over this for the people that are not here. So in your graphing calculator, you have a y equals button on that top row. And let's go to the y equals. If you have anything written in there, just hit your clear button. Okay, so you have nothing there. All right? And let's graph the first equation I have up there, which is x squared. Your x button is in the second row, second column. It's got x, a t, a Greek symbol of theta, and n. All right? And that's what you want to use. Do not use your alpha x. That's for something different. So you want to use that key. Some calculators, it'll say x var. That means x variable. But I think on these calculators now you'll have that button that says xt and then theta. That is a Greek symbol, and then n. Right. And then we want to square that. So you can use your caret key up to the 2, or you can hit your x squared button, which is in the first column. The second thing I want you to do is go to your zoom, which is on the top row there, the third button, zoom. Because my calculators, especially using my calculators, because the other classes use a calculator, they will change the window. What we want to do is we want a standard window. So we want to scroll down to number 6 where it says Z standard. And what a standard window means is that my x goes from -10 to a +10, and my y-axis goes from a -10 up to a +10. And that's called a standard window. And we're going to graph everything in a standard window. All right? Now we hit our, if you just hit that button, if you enter on that button, it'll graph. Or you can hit your graph button, which is in the top row of that, which is in the top row. It says a graph on it. All right? And we should get that parabola that I drew, the first one. If we want the parabola up there in red, which is x squared plus 3, we go back to our y equals. We hit your x squared and then just plus 3. And you can see, like Emily said, it just takes that parabola, takes that U shape, and it just moves it up 3 units. Yes? Go to your zoom menu, See the zoom in the top row? And you see where it says Z standard? Yep, and enter on that.
But what does that do?
Well, like I said, it puts your x-axis from -10 to a +10, and it puts your y-axis from a -10 to a +10. Okay?
Everything's in the class.
All right. Now, one of the examples they give you, it tells you to graph -1/4 x squared. And then compare it with the graph of y equals x squared. This is example number 2 on page 629. So let's see what that looks like. Well, first of all, in y1, I'm going to write x squared. And then I'm going to enter. On y2, I'm going to put -1/4, 1 divided by 4, x squared. We're going to compare the two. All right, so we're going to describe what you get. Then you can hit your graph button. We've already got our grid in standard form. This is the graph of y equals x squared. And we're going to compare it with now the red is y equals -1/4 x squared. Here's how you compare it. You're going to graph the two, and then you're going to say x squared is a parabola. It opens upward, normal width. The -1/4, it turns the parabola upside down. So it's an upside down U, and it is wider. Okay? You'd think it might be narrower because of the 1/4, but actually if you put a fraction in front of the x squared, it makes your parabola wider. What if we graph, let's graph this one in green. What do you think would happen if I graph y equals 2x squared?
Compared to both of them?
Yeah, what do you think would happen?
Would just
Before
get
you
bigger.
graph it, what do you think's going to happen? Nick?
Be higher than x squared,
What do you mean higher?
like the intersection point, I guess, would be higher. Like the bottom of the parabola would be higher.
No, you know, it's not like it's x squared plus 3, where you're raising up the whole parabola. This is 2x squared. What do you think, Mario?
It'd be steeper.
It'll be steeper. It'll look like this. The green is y equals 2x squared. The bigger the number, 3x squared, 4x squared, 5x squared, the steeper it gets, or the narrower that parabola gets. If the coefficient is a fraction, 1/2 x squared, 1/4 x squared, 1/8, that parabola opens up a little bit wider. Okay? So the directions might say, graph and make a table of values. I'm going to show you a little trick on table of values. Yes?
Is there ever a way to make a parabola go sideways?
Yes, there is.
You see that?
You'll be able to, I can show you what it looks like.
You do that?
It's actually two parabolas in one. It's y equals plus or minus the square root of x squared. That'll be the sideways parabola. We won't be doing that. You'll be getting that in algebra 2. Okay, so we'll clear those out of there. All right, now let me show you something for those two equations if you have to make a table of values. We can do like I did and plug in numbers. do the table of value on your calculator?
11.
Yeah?
Yeah.
All right.
You hit second table.
Okay, you have a table button on that top row of buttons up there where it says trace and where it says graph. All right, so that last button where it says graph, the second function says table. So if you hit second graph, now I don't know where your numbers start. I'm not sure where your numbers start. Maybe you want to start at, like I did, at -2. You have a button. See where it says window? That second function of window says table set. So hit second window. Now in my calculator, the table started at 37. Maybe you want to start it at, I don't know, -2. So let's just enter -2. And then go to your table, which is second graph. Now why are you getting two different numbers for y?
We have different equations.
Out of different equations, right? So in other words, for the first equation where it says y equals x squared, you have -2, 4, -1, 1, 0, 0, and so on. The second equation I had in my calculator was y equals -1/4 x squared. So when x is -2, y is -1. When x is -0.25, I'm sorry, when x is -1, y is -0.25. X is 0, y is 0, and so on. So you can read your table. So that's a good way that, and I think you guys know how to use your table. All right? All right. So look on page 632. I'll do a few of the problems and show you what I want. From problems 6 through 21, the direction says graph the function, compare the graph with the graph of y equals x squared. Here's what I want you to do. And let's take problem number 16. Y equals x squared minus 7. They want you to compare it with y equals x squared. Here's y equals x squared in black. If I were to graph y equals x squared minus 7, it's going to be the same width, and that's one of the things you can say. And the reason it's going to be the same width is because we just have an x squared. We don't have 2x squared, 1/2 x squared. It is the same width, but we're taking the parabola and we're dropping it down 7 units. That's how you compare. You can graph it like I just graphed on the board. That's all you have to do for problems 6 through 21.
So you just say like same width, 7 units down.
That's all you have to say, exactly, perfect. Same width, 7 units down. Okay? Now we have something called a vertex. We have a vertex of the red, and we have a vertex of that black parabola. Colin, look at the black parabola where it says y equals x squared. Can you tell me, what do you think that vertex might be? Do you know what a vertex is?
No.
Okay. I didn't know if you guys knew that or not. A vertex is where a graph changes direction. At what point does y equal x squared? This one right here. At what point does it change direction? Nick?
0.
At 0. And actually that point is 0, 0. And so the vertex is at 0, 0. Okay? Can you tell me what the vertex is of that red parabola? Is that what?
7, 0.
Not negative 7, 0.
0.
0, negative 7. Okay? All right? And so that if they ask you what the vertex is, you're just going to show that position where it changes direction. All right. And I know somebody had asked the other day, can we do some of the harder ones? So I'm going to do problem number 32. It says y equals negative 2/3 x squared plus 9. And I'll do this one in green.
You just have to grab it.
And I'm going to do this one on the same one where I did the black and the red up here, but I'll do it in green. All right. First of all, what does that negative mean?
But it's going to be upside down.
It's going to be upside down. Very good. Tell me what the 2/3 mean. Is it going to be wider or narrower?
Wider.
Wider. Very good. Now, what about the plus 9? What happens there?
It's going to be should be
Right. So it's going to move up 9 units. So that will look like this. 3, 4, 5, 6, 7, 8, 9. It's going to be narrower. It's going to go up 9 units. And can you tell me what the vertex is?
0,
0 and
9.
9. Right. It will be narrower.
Back to
If you
the
recall what I said before, if you have a fraction here, it's going to make, oh, you know what? You're right. It's going to be wider, isn't it? My mistake.
How would we put that into our calculator? Because mine just gave me a straight
You
line.
have to put it into
It's going to be wider.
Yeah, I put them in parentheses.
You put what in parentheses?
Oh, I mean, put the negative sign in parentheses.
I showed her how to do it. Like she did it wrong.
Yeah, and to put it in your calculator, you put it in exactly the way it's written, and you should be
I thought
okay.
you said to put it in parentheses.
Well, what we're doing is, we are not putting negative 2/3 into x. It's part of your equation.
Yeah.
So you don't have to put it in parentheses. It's not like it's a table of values.
So
Okay.
fractions are wider. And what's
Fractions
the
are
nearer
wider,
one?
and the bigger numbers, it's going to be narrower. Yep. So here it's just negative 2 divided by 3. Hit your x squared button, and then plus 9. There's the original one. And you can see it's wider, and then it's up 9 units. That's how we compare it. Wider, it opens down instead of opening up, and then it moves up 9 units. Okay, any questions on that? All right. So you're going to have to sketch some graphs. Your homework is going to be through 5 all.